In how many different ways, right, can 5 girls and 5 boys form a circle? So there is a circle such that the boys and the girls are alternate. Just now we discussed, if n people need to be seated in a circular table, if n people needs to be arranged in a circular table on n chairs, it will be n minus 1 factorial. Why? Because the first person can sit only in one way. So what I'll do is, first 5 boys I'll arrange. 1, 2, 3, 4, 5. 5 boys can be arranged in 5 minus 1 factorial, which is 4 factorial. So these are the boys which I am arranging: B1, B2, B3, B4, B5. 5 boys can be arranged in circular arrangement in 4 factorial. Remaining, how many? They need to be alternate. Now see here, how many positions are there? 1, 2, 3, 4, 5. 5 positions are left. 5 positions can be taken by 5 girls. 5 positions can be taken by 5 girls. This position can be filled in any of the 5 ways. This position can be filled in any of the 4 ways, 3 ways, 2 ways, 1 way. So this will be 5 factorial. So first boys arrangement, then girls arrangement. 4 factorial is 24. 5 factorial is 120. 5 factorial is 120. 24 digital sum is 6. 120 digital sum is 3. 6 3s are 18. 1 plus 8, it is 9. Answer digital sum should be 9. 2880. Digital sum is 9. These digital sum is 3, digital sum is 5, and digital sum it is 8. Again I am explaining. Boys and girls needs to be alternate. So I will first take 5 boys. 5 boys can be arranged in a circular arrangement in 5 minus 1 4 factorial. Boys are arranged in 4 factorial. Girls and boys needs to be alternate. So in between 2 boys there is a gap. 1 gap, 2nd gap, 3rd gap, 4th gap, 5th gap. 5 gaps can be filled by 5 girls. These gap can be taken by any one out of the 5 girls. So 5 positions, 4, 3, 2, 1. 5 into 4 into 3 into 2 into 1 is 120. 120 into 24. Either you multiply and get the answer as 2880 or use a digital sum. First one, I hope it is clear. Next one, half of the problem is solved if you read the question properly. Find the number of ways in which 6 rings can be worn in 3 fingers. 6 rings can be worn in 3 fingers. First ring can be there in 3 fingers. First ring can come in any of the 3 fingers in 3 ways. Second ring can come in any of the 3 fingers in 3 ways. Each ring can come in any of the 3 fingers. If it is 3 fingers, it can come in any of the 3 ways. Similarly, 6 rings can come in any of the 3 fingers. It is in 3 ways. 3, 3, 3, 3 power 6. 3 power 6 is nothing but 729. 3 power 6 is nothing but 729. Or in other words, 3 power any natural number. 3 power any natural number greater than or equivalent to 2. Answer digital sum will be 9. Answer digital sum will be 9. These odd. Odd power any number odd. It cannot be 720. Digital sum will be 9. These out, these out. Answer is nothing but 729. First ring can come in. First ring can come in any of the 3 fingers. Second ring, there is no restriction on the rings. The one ring, if one ring is present in one finger, other it is not present, nothing is mentioned. Rings are given, fingers are given. So one ring can get into any of the 3 fingers in 3 ways. Second ring can come in any of the 3 fingers in 3 ways. Sixth ring, it will be 3 power 6, which is nothing but 729. Second question, I hope it is clear. In how many ways can 5 men draw water from 5 taps? if no tap can be used more than once. So tap, suppose first man is there. He can open any of the 5 taps in 5 ways. No tap can be used more than once. Repetition not allowed. Repetition is not allowed. First tap can be opened by any of the 5 men. Second tap can be opened by any of the 4 men. It is 3, it is 2 and it is 1. Simple question. Fundamental principle of counting. 5 factorial, it is nothing but 120. First man can open any of the 5 taps. So one way it is over. Second man can open any of the other 4 taps. Third person any of the 3 taps. Fourth person 2 taps. Last person 1. 5 factorial, it is nothing but 120. 5 factorial, it is nothing but 120. How many 2-digit numbers? I wanted 2-digit numbers. Can be generated using the digits 1, 2, 3, 4. 1, 2, 3, 4. Repetition of the digits is not allowed. These place can be taken by any one out of the 4. This repetition is not allowed. Any one out of 3. So 4 into 3, it is nothing but 12. Any number multiplied by 3, answer digital sum should be 3. So 12. For larger values, this concept will be very useful. Most of them are exam related questions, sir. There are 3 places. One is place P, another is Q, another is R. Such that 3 roads connect. There are 3 ways to connect from P to Q. Okay. And 4 ways to connect from Q to R. Fundamental principle of counting. So 3 into 4, answer is nothing but 12. Answer is nothing but 12. P to Q, there are 3 ways. Q to R, there are 4 ways. For every one way from P to Q, there are 4 ways from Q to R. So 3 into 4, which is nothing but 12. Very, very easy question. 3 into 4, it is nothing but 12. Next one. There are 10 women and 15 men in an office. Okay. In how many ways can a person can be selected? A person can be either a woman or a man. A person can be either a woman or a man. So either a woman or a man. Our condition is nothing but plus. 10 plus 15, answer is nothing but 25. Don't do 10 into 15. He said that in how many ways a person can be selected. A person selected can be either a woman or a man. Even there are 25 people sitting in an office. In how many ways one person can be selected? 25C1. Answer is nothing but 25. That is also one way to look at it. Next one. There are 10 women and 15 men in an office. In how many ways a team of men and women can be selected? There are total 10 women in an office. W10. W1, W2 till W10. 15 men, M1, M2 till M15. So, first woman can team up with M1, M2 till 15. So, there are 15 ways. Similarly, second woman, M1, M2 till M15, again 15 ways. Like that, 10 women are there. So, each one can team up with any one out of the 15 men. So, 15 into 10. Answer is nothing but 150. 15 into 10, it is nothing but 150. So, 15 is divisible by 5. Answer should be divisible by 5. 150, it is the answer. Higher values use this concept. In how many ways? 3 boys can be seated on 5 chairs. There are 3 boys, B1, B2, B3. There are 5 chairs, C1, C2, C3, C4, C5. First boy can be seated in any one out of the 5 chairs in 5 ways. Second boy can sit in any one out of the 4 chairs in 4 ways. Third person can sit in any one out of the 3 chairs in 3 ways. 5 4s are 20, 23s are 60. Answer is nothing but 60. Easy question. Next one. There are 6 persons in an office. Okay, a group consists of 3 persons has to be formed. So out of 6 I need to select 3. Answer is nothing but 6C3. 6C3 is nothing but 6 into 5 into 4 divided by 1 into 2 into 3. 2 3s are 6 cancel, 5 4s are, it is nothing but 20. It is nothing but 20. 6 is a composite number. What is the prime number? Before 6 it is 5. Answer should be divisible by 5. All are divisible by 5. So 6 into 5 into 4 by 1 into 2 into 3. Right? I hope it is clear, right? Next one. Next question. There are 5 yellow, 4 green and 3 black balls in a bag. All the 12 balls are drawn one by one. All the 12 balls. Yellow means 5 yellows, Y1, Y2, Y3, Y4, Y5. All 5 yellows are there. Y1, I will replace it with 5 yellows are there. So this will be Y, 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 Y. 4 green are there. 4 green are there. 3 black are there. Total. So 12 colors can be, 12 balls can be arranged in 12 factorial. 5 yellow are there. So it is 5 factorial. 4 green are there. 4 factorial. 3 blue are there. 3 factorial. These nothing but 12 into 11 into 10. And so on up to 5 factorial. Divided by 5 factorial. Into 4 factorial into 3 factorial. Answer contains 11. Answer should be divisible by 11. Answer should be divisible by 11. Answer should be divisible by 11. What is the divisibility rule of 11? Take a group of 3 digits alternatively plus minus. Take a group of 3 digits alternatively plus minus. 230 minus 225, which is 205. 205 is not divisible by 11. 200 minus 121, which is nothing but 179. 179 not divisible by 11. These nothing but 720 minus 27, or you can take sum of the odd places minus sum of the even places. 4 plus 2 is 6, 3 minus 2 5. No, sum of the odd places, sum of the even places. Answer is nothing but 27,720. You don't need to calculate and waste your time. 12 factorial is 12 into 11 and so on up to 5 factorial. This will be cancelled. These all the terms will be cancelled by the other composite number into 11. Answer should be divisible by 11. 27720. Sum of the odd places minus sum of the even places. Sum of the odd places minus sum of the even places. Sum of odd places minus sum of even places. It should be divisible by 11. It should be divisible by 11. Sum of odd places minus sum of even places. Answer is 27,720. In how many ways 7 boys can be seated around a circular order? Circular, it is n minus 1 factorial. First person can sit in only one way. These is nothing but 6 factorial. These is nothing but 6 factorial. 6 into 5 factorial. 5 factorial is 120. 6 into 120, it is nothing but 720. Answer, it is nothing but 720. Or otherwise, you can go by the digital sum. 6 into 5 into 4 into 3 into 2 into 1. 6 3s are 18. 18 digital sum is 9. Answer digital sum should be 9. Answer digital sum should be 9. So these is nothing but it is not 9, it is not 9. So 5040, these number is not divisible by 7. 6 factorial is not divisible by 7. 5040 is divisible by 7. So answer is 720. In a bigger number, you can use it. Suppose instead of 7, If 12 boys it is there, if it is 12 boys, what will be the answer? 11 factorial. 11 factorial, it is nothing but 11 into 10 into 9 and so on up to 3 into 2 into 1. Answer should be divisible by which number? 9. Answer should also be divisible by which number? 11. I hope the idea it is clear. Bigger numbers make use of answer options digital sum. Now if you see here, in how many ways 7 birds can be arranged to form a necklace? Suppose for example, 1 minute sir, I will visually show it. Praveen, 1 minute, I will show it visually. Okay, necklace unda? Devuddi? Now, try to visualize it, sir. Suppose, for example, I will show you visually so that you will understand it very, very clearly. Now, see here. For example, this is a necklace. Visualize it, sir. This is a necklace. This is a necklace. This is nothing but in the form of a circle. Yes or no? Circle, it is nothing but 7 minus 1 factorial. This is nothing but a, assume that this is nothing but a necklace. In this necklace, now what we can do is, I remove it, shift it to this direction and I will wear it again. Again, the form order does not changes. Again, I am explaining. Assume that it is a necklace. This is a necklace. This is nothing but circular arrangement. It is 6 factorial. Exactly, necklace is like this. I removed it. After removing it, I shifted it like this. And I wore it. So, if I shift it like this and I wore it, the order does not changes. So, what is the difference between circular arrangement and a necklace? In a necklace, it is a circular arrangement, n minus 1 factorial. Wear it, remove it, shift it, and again wear it. It is n minus 1 factorial by 2. N minus 1 factorial by 2. This is nothing but 7 minus 1 factorial by 2. I hope the idea is clear. Again, I am saying, it is a circular arrangement. Wear it, remove it, shift it, again wear it. The order does not changes in a necklace. So, this is nothing but 6 factorial by 2. 6 factorial by 2. This is nothing but 6 factorial is 720. 720 by 2. Answer is nothing but 360. Answer is nothing but 360. This is nothing but 6 into 5 into 4 into 3 into 2 into 1 divided by 2. 2 ones are 2 threes are 3 threes are 9. Answer digital sum should be 9. Answer digital sum should be 9. So 3 5s are 15, 66 are 360. It cannot be 720. In a necklace, why it is n minus 1 factorial by 2? I hope the idea it is clear. N minus 1 factorial by 2. Next one. In how many ways can a team of 5 persons, I need a team of 5 persons, formed out of 10 persons, I need to form a team of 5 persons from a team of 10 persons such that 2 particular persons should be included in each team. Here also it should be included. So, out of 5, 2 should be included. Remaining selection is nothing but 3 persons. Here also I need to include mandatorily 2 persons. So, remaining it is nothing but 8 persons. So, from 8 persons I need to select 3, which is nothing but 8C3. Which is nothing but 8C3. 8C3 is 8 into 7 into 6 divided by 1 into 2 into 3. 6 cancel. Answer should be 8 sevens are 56. Answer is 8 sevens are 56. Answer should be divisible by 8 and 7. 8 and 7. 28 is not divisible by 8. I need to select a team of 5 persons from 10 persons. 2 particular persons should be included. Out of 10, 2 are already included. They have already been selected. Remaining how many are there? 8. Out of 5, 2 has already been included. Remaining how many are there? 3. From 8 persons, select any 3, which is nothing but 8C3. Which is nothing but 8C3. So, in a team of 5 people, I need to select a team of 5 people from 10 persons such that 2 particular persons should not be included in any team. 2 people should not be included. 2 people should not be included. So, they are not included here. So, from 8, select 5. 8C5. So, automatically here also you can select, you can reject 2. 8C5 is nothing but 8C3. Again, the answer is 56. 2 persons should not be included. 2 persons should not be included. In the 10 persons, if 2 persons are not included, obviously in that 5 people, that 2 will not come. So, automatically it will be 8C5, which is 8C3. Now, see here. How many triangles? These are the questions based on geometrical figures. These are the questions based on geometrical figures. What is this? We will see. How many triangles can be formed by joining the vertices of an octagon? Octagon is nothing but a polygon with 8 points. With 8 points. To draw a triangle, I need 3 points. To draw a triangle, I need 3 points. I got 8 points, therefore an octagon is formed. In that 8 points, to draw a triangle, I need to select 3 points. Out of 8, select any 3. Out of 8, select any 3. These are nothing but 8 into 7 into 6. Divided by 1 into 2 into 3. So, how many triangles can be formed? By joining the vertices of a triangle, which of an octagon, answer is 3. So, 8 points are there. To draw a triangle, I need to select 3 points. For example, 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. A, B, C, D, E, F, G and H. Here 4. I need to select any 3 points. Suppose if I select this, A to C, C to E, C to E. These is nothing but a triangle. Out of 8 points, I need to select any 3. Out of 8, I need to select any 3. Answer is nothing but 8C3. Idea clear, right? Next one. There are 9 horizontal lines and 9 vertical lines in a chessboard. How many rectangles can be formed in a chessboard? To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. Any 2 horizontal lines and any 2 vertical lines, I will get a rectangle. I need to select 2 horizontal lines from 9 horizontal lines. I need to select 2 vertical lines from 9 vertical lines. Out of 9, select any 2 horizontal lines and these into. Out of any 9 vertical lines, select any 2. So, these are nothing but 9 into 8 by 2 into 9 into 8 by 2. These 2 ones are 2 fours are. It is 36 into 36. Unit digit is 6 6 are 36. Unit digit should be 6. So, answer is 1296. Answer is 1296. To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. I got 9 horizontal lines and 9 vertical lines. Out of 9, select any 2. And condition is into. Out of 9, select any 2. 9C2 into 9C2. 36 whole square is anyway 1296. Or you can use a digital sum. 36 digital sum is 9. 9 into 9. 9 nines are 81, 9. Answer digital sum should be 9. 4 plus 2 plus 1, 7, not possible. 64, not possible. 920, not possible. So answer is 1296. Digital sum is 9. To draw a rectangle, I require 2 horizontal lines and 2 vertical lines. I require 2 horizontal lines and 2 vertical lines. Next one, concept. Please write down this concept. Number of diagonals. Number of diagonals in a polygon. Number of diagonals in a polygon. How to determine the number of diagonals in a polygon? Suppose if there are 4 points. If there are 4 points. Now see here. There are 4 points. To draw a line, I need 2 points. To draw a line, I need 2 points. I need 2 points. So out of 4, I will select any 2 points. Therefore, I can draw a line. So 1 line, 2nd line, 3rd line, 4th line, 5th line, 6th line. So 4C2 will give you number of straight lines. 4C2 will give you number of straight lines. Yes or no? In a 4 points. In that one, these are called adjacent lines. These are called diagonal lines. So diagonal lines is nothing but total number of straight lines. Total number of straight lines minus adjacent lines. I hope the idea it is clear. Total number of straight lines, if n points are there, to draw a straight line I require nC2. Adjacent lines are n. These nothing but n into n minus 1 by 2 minus n, which is nothing but n into n minus 3 by 2. Number of diagonals in a polygon. Number of diagonals in a polygon is given by the notation n into n minus 3 by 2. Number of diagonals in a polygon, it is given by the notation n into n minus 3 by 2. N into n minus 3 by 2. From where we got? From n points to draw a straight line, I require 2 points. Number of straight lines will be nC2, out of which adjacent lines will be n. nC2 minus n. Answer is n into n minus 3 by 2. I want decagon. Decagon, it is nothing but n value 10. Number of diagonals will be 10 into 10 minus 3 by 2. 2 5s are 10. 5 7s are 35. Answer for this question is nothing but 35. Number of diagonals of a decagon is nothing but 35. Idea it is clear. Number of diagonals is given by the notation nC2 minus n, or n, if I calculate it, I will get the answer n into n minus 3 by 2. Number of diagonals is given by n into n minus 3 by 2. Find the number of triangles. Whenever this kind of geometrical figure questions are there, to draw a triangle, how many points we require? 3 points. That can be formed using 14 points, in which 4 points are collinear. 4 points are collinear. Suppose 14 points are there. 1, 2, 3, 4. Right? 4 points are collinear. So 1, 2, 3, 6, 7, 8, 9 and 10. So there are 11, 12 are, we will write down like this. There are 14 points are there. In that 14 points, I require a number of triangles. To draw a triangle, I need to select 3 points. I need to select 3 points. So if only 14 points are there, number of triangles will be 14C3. But in that one, 4 points are collinear. 4 points are collinear. 4 points are collinear. When I say collinear, these are nothing but this one. 4 points are collinear. In these collinear means they all lie. They all lie in same straight line. They all lie in same straight line. So out of which, can I draw a triangle if it is lying in a straight line? No. So answer is 14C3. Answer is 14C3. Because from the 4 points which are collinear, I cannot draw a triangle. I hope it is clear. Now 14C3, it is nothing but 14 into 13 into 12 by 1 minute, sir. Right? 14 points are there. I need to select 3 points. 4 points are collinear. Okay. Now see here. 4 points are collinear. One small mistake which we did it. 14 points are there. If 14 points are there in a plane such that 4 points are collinear, that means 10 points are here, 10 points are non-collinear. Am I right? One small mistake. 10 points are non-collinear. 10 points are non-collinear and 4 points are collinear. 4 points are collinear. In that 10 points non-collinear, collinear means they all lie on the same line. If they lie on the same line, triangles cannot be formed. Triangles cannot be formed. Out of 10 points which are non-collinear, non-collinear means they do not lie on the same line. I need to draw triangle. To draw a triangle, I need to select 3 points. So out of 10, if I select 3, these is nothing but 10 into 9 into 8 divided by 3 into 2 into 1. 3 into 2 into 1. 6. 6, it is nothing but 120. Answer is nothing but 120. I hope the idea it is clear. Out of 14 points, 10 points are non-collinear, 4 points are collinear. If collinear means all the 4 lie on the same line. If they lie on the same line, then triangle cannot be formed. So in this one, triangle cannot be formed. Out of 10 points, select 3 points are there. So out of 10, it is nothing but 10C3. 10C3. I hope the idea is clear. Do it very slowly, you will get an idea. Find the sum of all the 4-digit numbers without repetition. Yesterday we discussed units place, tens place, hundreds place and thousands place. Thousands place or hundreds place or tens place or units place. Either 2 can come or 3 can come or 4 can come or 5 can come. If 2 comes, remaining 3 digits, 3 places, it will be 6. These is nothing but 4 ones into 9, 12, 14, 14 into 6, 14 into 6. Here you can use the concept of digital sum. 4 ones, it is nothing but 4. 1 plus 4, it is 5. It is nothing but 6. So 4 5s are 20, 2 6s are 120. 120 digital sum is nothing but 3. Answer digital sum should be 3. 3 out, 9 out, it is 6. 3 out, 9 out, 2 plus 1, 3. It is 4. It is out. Anyway, 6 4s are 24, 4 1s are 4. 2, it is not possible. 3 out, 3 out. 3 plus 3, it is 6. 6 plus 6, 12. 12 plus 9, 21. 2 plus 1, 3. I hope the idea it is clear. 2 can come either in thousands place or in hundreds place or in tens place or in units place. If 2 is present in the leftmost, remaining 3 places, it can come in 3 factorial ways. 4 ones into 14 into 6. Or you can also do like this. 1000 plus 100 plus 10 plus 1 into, see here sir, 1 plus, sorry, 1 is not there, 2 plus 3 plus 4 plus 5 into 6. These 9, 12, 14. 14 is 2 into 7. Answer should be divisible by 7. Answer should be divisible by 7. Take a group of 3 digits, alternatively plus minus. Alternatively plus minus. If I take these unit digit is 4, it is out. So if I take D option, 93324, take a group of 3 digits, alternatively plus minus 324 minus 93. 14, 4 minus 3, it is nothing but 1. So 32 minus 9, which is 231. 231 is divisible by 7. 231 is divisible by 7. So answer is option number D, 93324. 93324. I hope the idea it is clear. You don't need to multiply and show your mathematical intelligence. Smartly you can solve it. Now, in a birthday party, every person, suppose if there are 4 friends are there, F1, F2, F3, F4, number of handshakes. Previous year exam related questions, sir. Number of handshakes. F1 shakes hands with F2. That means if I am shaking hand with you, that means F1 with F2 over, F2 with F1 over. F2 is shaking hands with F3. F3 already shook hands with F2. It is also over. Next one, F2 will shake hands with F4. Next it is nothing but F3 will shake hands with F4. Next one, F1 will shake hands with F4. Next one, F1, F2, F1, F3, it is not over. So F1 will shake hands with F3. All the combinations are over. F1 with F2, F1 with F3, F1 with F4. 3 cases. F2 with F1 already over. F2 with F3, F2 with F4. 2 cases. F3. So total 6 handshakes are there. If n people are there, suppose to shake hands, I require 2 hands. So number of handshakes is nothing but NC2. Number of handshakes, it is nothing but NC2. NC2, it is nothing but 28. NC2 is n into n minus 1 by 2. It is 28. n into n minus 1 is 56. So n value, it is nothing but 8. N value, it is nothing but 8. If n people are there, I need 2 people to shake hands. I need two people to shake hands. Out of n people, I require 2 people to shake hands. So number of handshakes, it is given by NC2. NC2, it is nothing but n into n minus 1 by 2. This is the most high frequency question which came in many exams, sir. Number of handshakes are nothing but NC2. Number of handshakes are nothing but NC2. Now see here. There are 8 points in a plane. There are total 8 points in a plane. Okay. Out of which 3 are collinear. That means 5 points are not collinear. 5 points are non-collinear. 5 points are not collinear. 5 points are not collinear. Now 1 minute, sir. If it is 8 points are there, forget about this condition. 8 points are there. To draw a straight line, I require 2 points. I require 2 points. So total number of straight lines will be, if 8 points are there, total number of straight lines will be 8C2. 8C2, it is nothing but 8 into 7 by 2, which is nothing but 28 straight lines. In that 28 straight lines, 3 points are collinear. 3 points are collinear. So if 3 points are collinear, it is nothing but same line. In these 8 points, I have taken this case. So 8C2, I have to subtract minus 3C2 because I assumed that these three are not collinear. I assumed that these three are not collinear. So 8C2 minus 3C2. These collinear means there will be one line which touches all the points, which is nothing but 8C2 minus 3C2 plus 1. These are nothing but the total number of straight lines. In that total number of straight lines, these are the lines which are formed based where three are collinear. Where three are collinear. So out of 8C2 total lines, number of lines which I took it, assuming that these three are not collinear, it is 3C2, but they are collinear, so I need to subtract. All the collinear points, they will draw on a line. One more extra line I will get. Answer is nothing but 8C2 minus 3C2 plus 1. Quadrilateral, octagon. Octagon is nothing but 8 points are there. Octagon, it is nothing but 8 points are there. Quadrilateral is formed by joining any 4 points. Quadrilateral is formed by joining any 4 points. Out of 8 points, select any 4. Out of 8 points, select any 4. 8 factorial by 4 factorial, 4 factorial, which is nothing but 8 into 7 into 6 into 5 into 4 factorial by 4 factorial into 24. These cancel. Answer should be divisible by 7. 65 not divisible by 7. 74 not divisible by 7. 60 not divisible by 7. Answer is nothing but 70. Answer is nothing but 70. Now, how many straight lines can be formed? To draw a straight line, I require 2 points. Can be formed by joining 12 points on a plane. So, there are 12 points are there on a plane. In these 12 points on a plane, to draw a straight line, how many points I require? 2 points I require. Out of 12, select any 2 points. NC2 is 12 into 11 by 2. Answer is nothing but 66. Answer, it is nothing but 66. I hope it is clear. Out of 12 points, I require 2 points to draw a straight line. So, out of 2, select any 2. 12C2, which is nothing but 66. Next, please write down a note. Write down a note. If NCR is equivalent to NCS, there are 2 conditions that will be there. Either R equivalent to S or R plus S equivalent to N. Either R equivalent to S or R plus S equivalent to N. So, NC8 equivalent to NC27. 8 and 27 are not equal. So, 8 plus 27, which is nothing but 35. So, N is nothing but 35. Very, very important note. If NCR is equivalent to NCS, either R equivalent to S or R plus S equivalent to N. Very, very important. R plus S equivalent to N. NCR equivalent to NCS. A notation based problem. Next one. Next question. All are previous year examination questions, sir. In how many ways 10 students can be arranged in row? So, 10 students can be arranged in row in 10 factorial. Answer is nothing but 10 factorial. If it is in a circle, then it will be 9 factorial, right? Row means row, it is nothing but a linear arrangement. Row will become an linear arrangement. Row will become an linear arrangement. I hope the idea it is clear. Next one. Find the number of triangles that can be drawn. Triangle means I require 3 points. I require 3 points. Total how many points are given? N points are given. I require 3 non-collinear points to draw a triangle. Out of N points, select any 3. I will get the number of triangles. Answer for this question is nothing but NC3. Answer, it is nothing but NC3. In how many ways can 10 books be arranged? 10 books be arranged. B1, B2 and so on up to B10 and so on up to B10 can be arranged on a shelf such that a particular pair of books is always together. Particular pair, it is always together. So if I take B9 and B10 are together, B1 to B8, 8, and these, if I take it as one unit, 8 plus 1, 9, 9 factorial. These two can be arranged among themselves in two ways. 9 factorial into 2 factorial. Answer, it is nothing but 9 factorial into 2 factorial. So, if 2 books are together, total 10 books are there. 8 books, 9th book and 10th book, put it as one unit. So, total it will be 9 factorial. These 2 books can be arranged among themselves in two ways. 9 factorial into 2 factorial. Next one. In how many ways can 10 books be arranged on a shelf such that a particular book will never be together? So, it is nothing but total arrangement minus books kept together, minus books kept together. So, total arrangement, it is nothing but 10 factorial. These is nothing but 9 factorial into 2 factorial. These is nothing but 10 into 9 factorial minus 9 factorial into 2 factorial. 9 factorial common. 10 minus 2, it is nothing but 8. Answer is nothing but 9 factorial into 8. Answer, it is nothing but 9 factorial into 8. I hope the idea it is clear. Right? So, particular pair of books will never be together. It is nothing but total arrangement minus all the ways where books are kept together. Total arrangement, it is nothing but 10 factorial. Arranging together, it is nothing but 9 factorial into 2 factorial. 9 factorial into 2 factorial. Next question. Arun wants to send invitation to his 7 friends. Okay. In how many ways can he send the invitation? Right? Can we send the invitation? If he has 4 servants to carry the invitation letters, total Arun has to send it to 7 friends. 7 friends. Now, first friend can be invited by any of the 4 servants in 4 ways. Second friend can also be invited by any of the 4 servants in 4 ways. Third friend can be invited by any out of the 4 servants in 4 ways. Seventh friend can be invited by 4 servants in 4. Answer is nothing but 4 power 7. 4 power odd number. 4 power odd number. Unit digit is always 4. 4 power odd number. Unit digit is always 4. Answer is 16384. Answer for this question is nothing but 16384. First friend can be invited by any of the 4 servants. Second friend can be invited by any of the 4 servants. Third friend, seventh friend also, it is by 4. I hope the idea it is clear. How many 3-digit numbers? I want a 3-digit numbers. It is divisible by 5. Can be formed using the digits 0 to 9. 0 to 9, total 10 digits I need to use. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it is divisible by 5, unit digit will be either 0 or 5. Unit digit will be either 0 or 5. How many 3-digit numbers? Left side, if the unit digit is 0, here 0 cannot come. 0 cannot come. So, here 1 to 9, total 9 numbers can come. Out of 10 digits, this digit is fixed and this digit is fixed. This is nothing but 8. This is nothing but 8. 9 into 8. If it is 5, none of the digits is repeated, right? So, if it is 5, here 0 cannot come. So, here it is 1 to 9. Here it is 1 to 9. Here it is nothing but Here it is out of 0 to 9. These digit is fixed. These digit is fixed. So remaining it is 8. Remaining it is 8. I hope it is clear, or again otherwise neatly I will solve. Total it is a 3-digit number. It is a 3-digit number. 3-digit number totally how many digits I can use? 0, 1, 2, 3, 4, 5, 6. 7, 8, 9. 7, 8, 9. Now see here. If the unit digit is 0, if the unit digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here any one out of the 9 will come. Out of 10 digits, 2 digits are fixed. These is nothing but into 2. Here unit digit it is 5. If it is 5, here 1 to 9, here 1 to 9, 0 cannot come, 0 cannot come, 5 also cannot come. Are you all with me? So total, how many digits can come? 8 can come. 5 cannot come, 0 cannot come, 8. Out of 10 digits, 2 are fixed. So it is nothing but remaining 8. So it is nothing but 9 into 8 plus 8 into 8. 72 plus 64. Answer for this question is 136. Answer for this question is nothing but 136. If the for a 3-digit number to be divisible by 5, unit digit will be 0 or 5. Unit digit will be 0 or 5. Leftmost 0 cannot come. That means 1 to 9, any of the 9 numbers can come. Leftmost, rightmost, remaining 8 can come. If the unit digit is 5, leftmost 5 cannot come and 0 cannot come. 8 into 8. 72 plus 64. Answer is nothing but 136. Next one. How many numbers between 100 and 1000? 100 and 1000. 100 and 1000 means I require a 3-digit number. A can be 0. These 3, 4, 5, 0, 6, 7. 3, 4, 5 and 0, 6, 7. Between 100 and 1000 is, the largest number is 999. So A, B, C. Repetition of the digits is not allowed because it's a 3-digit number. Because it's a 3-digit number. It is a 3-digit number. A can take 3, 4, 5, 6, 7. So total 5 numbers can come. Total 5 numbers, 1 minute sir. How many numbers between 100 and 1000? 100 and 1000 means 3, 4, 5, 6, 7 cannot come. Yes, so 100 and 1000 means 300, 400, 500 it can come. Sorry, I am mistaken. So I am thinking that it is a 4-digit number. So here it is nothing but 3 can come, 4 can come, 5 can come, 6 can come and 7 can come. So here 3, 4, 5, 6, 7. Total how many cases are there? 5 cases are there. Answer should be divisible by 5. 142 it is out. B. B here 1 digit it is already taken. If 1 digit if it is already taken, remaining 5 digits will come. Remaining 5 digits will come. Out of 6, 2 digits are already fixed. Remaining 4 will come. So answer is nothing but 5 into 5 into 4. So total answer is nothing but 100 numbers that can be formed using the digits 3, 4, 5, 0, 6, 7. Leftmost 0 cannot come. 3 can come, 4 can come, 5 can come, 6 can come, 7 can come. 5 cases it can come. Out of 6 digits, leftmost 1 digit is fixed. Remaining 5 digits can come. Out of 6 digits, 2 digits are fixed. Remaining 4 can come. So 5 into 5 into 4. Answer is nothing but 100. Easy question. Just we have to do little slowly. A telegraph has 10 arms. Each arm can take 5 distinct positions. 5 distinct positions. So it is nothing but first arm can take, right? There are total 10 arms are there. So first arm can take any of the 5 positions. Second arm can take any of the 5 positions. 10th arm can take any of the 5 positions. So total it is 5 power 10. But there is a position where all of them are on the rest. All of them, it is including position of the rest. All of them are on the rest. So answer is 5 power 10 minus 1. These are all very, very easy questions, sir. These are all very, very easy questions. There are 2 books. There are 2 books, each of 5 volumes. One book is 5 volumes. Next book also it is 5 volumes. Next, another 2 books, each of 2 volumes. Third book it is 2 volumes. Fourth book also it is 2 volumes. Read the question. If I read the question, in how many ways can these books be arranged? These 4 books can be arranged in 4 factorial. 4 factorial. These 5 volumes can be arranged in 5 factorial. Second book, 5 volumes can be arranged in 5 factorial. Third book, 2 volumes can be arranged in 2 factorial. Fourth book, 2 volumes can be arranged in 2 factorial. So answer is 4 factorial into 5 factorial into 5 factorial into 2 factorial into 2 factorial. I hope